Hi guys, this week we are talking about how scientists use fossils to determine the age of rocks and explore what organisms existed in the past. First of all, let's talk about what a fossil is. So a fossil is a trace or remain of a living thing. Most commonly you think about dinosaur bones or footprints, and they give information about the organism. Keep in mind that it takes a really, really long time to make a fossil, around 10,000 years or more. And not every fossil is actual remains of the organism. It could be an impression or a piece of evidence or their tooth or their shell. Original remains are a rare type of fossil, but they are the actual body parts of the organism. They're found in places that prevent decay, which is why they're so rare. This is something like ice. We've been talking about ice cores this week, so something like that would preserve a living thing. Amber, which is what you see in the movie Jurassic Park with the mosquito, a sticky tree sap that would trap the insect, or tar, which is a really sticky material that could preserve a living thing. Fossils are formed in sedimentary rock, which is the type of rock that builds up over time by sand or sediment or soil. The reason they're found in sedimentary rock is that the heat and pressure that's found in igneous and metamorphic rock can destroy living things and doesn't allow them to be preserved over time. There are 4 types of fossils. The first one is molds and casts. Molds are formed when sediments bury an organism and the sediments change into rock. And then the organism decays, which leaves a hole in the rock that was the shape of the organism. And then the cast is when that mold is filled with sand or mud that then hardens into the shape of the organism. So a mold and cast of a seashell would not be an actual seashell, but would be the exact same size and shape as the original seashell. A petrified fossil forms when minerals soak into the buried remains, which changes them into rock. So a lot of times this is petrified wood, which means that a piece of wood has turned to stone. The third type is carbon film, which happens when organisms decay, and then all that's left of them is just an imprint of the carbon atoms that used to be part of that body. They show soft parts, which rarely can be seen in other types of fossils. And then trace fossils, which are the organism's footprints or trails, not parts of their body, but just trails that they've left behind. So what we use fossils for is over time, we can use this thing called the fossil record, which is the millions of fossils that have been collected and observed to compare ancient organisms to current organisms, as well as see when different things were going extinct. So those extinction events that you learned about last week in your Canvas, a lot of those are things that we know about because of huge changes that occurred in the fossil record. And then similarly with plants, we can use tree rings to see the weather patterns in the area depending on the size of the rings. So a really thin ring means that it was a dry year. A thick ring in the tree would mean that it was a year with good rainfall. We also can use ice cores, which we talked about last week, to analyze air quality, volcanic activity, those sorts of things, so we can see how the atmosphere of Earth has changed by looking at the ice. Sedimentary rock can be used to show relative age, which is just the age that something is compared to something else. So we can use sedimentary rock to say that a fossil is older than another fossil. And we use the law of superposition to do that, which basically just means that the things that are on the bottom are the oldest and the things that are on the top are the youngest, because you can think about this as layers in a cake where the first layer got laid down first, it would be the oldest, the icing got laid down last, that would be the youngest. So rock layers can move over time because tectonic plates are always moving, which is why we had Pangea in the past, and now our continents are more spread apart. You might know that they're actually still moving, the continents. so their position is constantly changing, just very slowly. Tectonic plates can cause rock layers to get bent and folded, which is called unconformity. And so that can make it a little bit trickier to find the age of the rocks. Also, igneous rock can disrupt sedimentary rock layers because it's so hot. So if there's a volcanic eruption, magma can force its way through the layers. If that happens, the layers that are being cut through are older than the igneous rock or the magma that's running through those rocks, which makes sense. So here's an image just so you can see this happening. The schist is on the bottom, so this would be the oldest. After that would come the sandstone, limestone, and shale. Now, the next oldest would be the basalt, because what happened was the volcano erupted and that hot lava was here on the top, which used to be the top. So the shale was the top when the volcano erupted. The magma cut through these older layers and then hardened into rock. Finally, after all that cooled, the conglomerate laid down on top of all that. So conglomerate would be the youngest. All this is called the law of superposition. Index fossils are important fossils that we know what period of time those living things lived in. So if you find an index fossil in a layer of rock, you can determine the relative age of that rock because that fossil is there. So the example there is that a type of shellfish we know lived from 144 million to 65 million years ago. And so if you found a fossil of that in a rock layer, you would know the age of the rock layer is the same as the age of the fossil. The other type of age is absolute age. So relative age is knowing just about what time it occurred compared to something else. Absolute age is knowing exactly how old that fossil is. And that is determined through half-life, which is the time it takes for half the atoms in a radioactive sample to break down. Usually this is done using carbon-14 because all living things are made of carbon. And so scientists can detect the amount of carbon that's in that fossil or in that preserved organism, and that way determine by how much carbon is left, how much has decayed, and therefore how old the organism is. So if half of the carbon is left that was in that organism, then the scientists would know that fossil is 5,730 years old. All right, that's it this week. Make sure to do your discussion posts, and I'll see you guys next time. Bye.